Welcome to the Greek Ship Corrosion channel. My name is احتشام زاده. I'm a researcher in the field of corrosion and protection of materials. Chapter 4, Section 2, Electrode Kinetics and Kinetics of Corrosion, Effect of Chloride Ion and Corrosion of Steel in Aqueous Solutions. The references are shown here. The Greek ship, Shipwrecks and Maritime Incidents in 1966. The Greek ship is the nickname of Kola F. She was built in 1943 under the name Empire Trumpet. From 1946 to 1966, she passed through a series of British and Iranian owners and various changes of name. Her final owners were Greek. On July 25, 1966, Kola F ran aground on the southwestern coast of Kish Island in the Persian Gulf. This wrecked and corroded ship has become a tourist attraction in Iran. This steel ship is exposed to uniform corrosion, pitting corrosion, and microbiologically induced corrosion (MIC) in the marine environment. Metal, inner stratum, outer stratum, seawater, shells, other microorganisms, sediments. Corrosion of seas in aqueous environments containing chloride ions. Chloride ion is an important corrosion factor in the marine environment. Chloride ion has a small radius and strong permeability, which can destroy the oxide film on the surface of marine structural steel. The uneven absorption of chloride ion on the metal surface will cause pitting corrosion. In this case, catalytic reaction is O2 plus 2H2O plus 4 electrons yields 4 OH-, and andic reaction is Fe yields Fe2 plus 2 electrons. Chloride ions are not uniformly adsorbed on metal surface, so metal material in the adsorbed part are activated, thereby inducing pitting corrosion. Chloride ion is an activator of pitting corrosion. When chloride concentration is higher than the minimum value, corrosion pit would be activated for metastable growth. The metastable pitting potential EM has the following linear relationship with the logarithm of chloride ion concentration in the solution. EM equals minus 37 logarithm of chloride ion concentration minus 212. Chloride ion would not only affect the corrosion kinetics but affect the morphology and protective characteristics of the corrosion product's film. Local chloride ions on a metal surface would promote the formation of unstable rust layer on steel, reducing the protective effect of the rust layer. Fe2 plus 2 OH- yields FeOH2. 4 FeOH2 plus 2H2O plus O2 yields 4 FeOH3. As the concentration of chloride ion increased, the content of beta FeOOH in corrosion products increased. Beta FeOOH is a loose and porous corrosion product. Chloride ion would reach the matrix through its pores and promote the further development of pitting corrosion. Fe2 plus 2H- yields FeOH2. 4 FeOH2 plus 2H2O plus O2 equals 4 FeOH3. FeOH3 equals FeOOH plus H2O. 2 FeOOH equals Fe2O3 plus H2O. Chloride ion is adsorbed on the defects of metal surface, which hinders the formation of protective film on metal surface. Thus, the occurrence of pitting corrosion is promoted. Fe2 plus in the pit diffuses out of the hole and the pH value of the solution at the orifice increases and secondary reaction occurs. 4FeOH2 plus 2H2O plus O2 equals 4FeOH3. FeOH3 is generated at the orifice and deposited to form a barrier layer to hinder the exchange of solution. Details of pitting corrosion mechanism are discussed in the video titled Chapter 3, Section 2, number E7. Pitting propagation. The material exchange inside and outside the pit is limited, and a blocking area is formed in the pit. A low oxygen accumulation in the pit and a high oxygen accumulation outside the pit. The concentration of metal cations in the pits is higher. To maintain the electronegativity of the solution, chloride ions in the solution outside the pits migrate and accumulate in the pits. Cl minus, Cl minus, Cl minus, Cl minus. pH drop in the pit. Chloride ions and metal ions in the pits generate a high concentration of metal chlorides, and then the metal chlorides are hydrolyzed. MCl plus H2O equals MOH plus HCl. FeCl2 plus 2H2O yields FeOH2 plus 2H plus 2Cl minus. pH decreases as hydrogen ion concentration increases. Corrosion behavior of DSHS steel in sodium chloride aqueous solution. The main corrosion products of heat-treated dispersion-strengthened high-strength steel after immersion in sodium chloride solution for 7 days were alpha FeOOH, gamma FeOOH, and Fe3O4. Gamma FeOOH is a corrosion product with low stability, and it is also the main component of the initial rust layer. After a certain oxidation-reduction reaction, it would be transformed into Fe3O4, which is more thermodynamically stable. 8 FeOOH plus Fe2 plus 2 electrons yields 3 Fe3O4 plus 4 H2O. Fe3O4 would be oxidized again to alpha FeOOH under the action of oxygen. 3 Fe3O4 plus 9 over 2 H2O plus 3 over 4 O2 yields 9 FeOOH. Alpha FeOOH is the protective phase in the rust layer. The protection of each corrosion product is as follows. Alpha FeOOH is more protective than Fe3O4, and Fe3O4 is more protective than gamma FeOOH. Dual effect of chloride ion and oxygen. With increasing chloride ion content, the dissolved oxygen in the solution decreased. Therefore, the cathodic depolarization is weakened, and the corrosion rate of the intended steel is the lowest in 5 weight% NaCl solution among 0, 0.5, 2, 3.5, and 5 weight% NaCl. The corrosion products of DSHS steel in NaCl solution were mainly alpha FeOOH, gamma FeOOH, and Fe3O4. In 5 weight% sodium chloride solution, the content of chloride ion is high, resulting in the decrease of dissolved oxygen. So the formation of alpha FeOOH is inhibited, and the protection of corrosion products is weakened. Synergistic effect of chloride ion and oxygen. The effects of chloride on the corrosion behavior of carbon steel in 1/10 molar sodium bicarbonate plus 1/10 molar sodium chloride solution with dissolved oxygen of different concentrations are as follows. The corrosion mass loss of the carbon steel in this solution is significantly increased with increasing of dissolved oxygen concentrations attributed to the competition of the deteriorating effect of chloride ion and the repairing effect of dissolved oxygen on the oxide film. With the immersion time going by, the corrosion potential of the steel is promoted as a result of the accumulation of the corrosion products. However, the rust layer is loose and porous due to the deteriorating effect of chloride ion, which decreases the reduction resistance of oxygen. Meanwhile, the porous rust layer could be repaired by the depolarization of oxygen. Under the synergistic effect of chloride ion and oxygen, the corrosion of the steel is accelerated during the repeated process of dissolution and repair of the oxide film. Challenge number 23. Thank you for your time and attention. If you like to challenge yourself, please answer this question in the comments below. The concentration of chloride in seawater is roughly 19,000 milligrams per liter. In contrast, fresh groundwater typically has chloride concentration less than 100 milligrams per liter. The saltiest ocean water is in the Red Sea and in the Persian Gulf region due to very high evaporation and little fresh water inflow. How much is the salinity of the Persian Gulf?